Hello everyone, I would just like to in this video go over some solutions to questions that were assigned last week. So on Friday your class would have been assigned these following questions. So I'm going to very quickly go through some solutions. Check your answers before you continue with finishing up lesson 6 today. In question 1a, the easiest way for us to approach this area is simply to cut the shape in half. This would be one way to approach it. So I'm cutting the shape in half right here. In order to find the length that I've just overlapped in pink here, I will have to take x plus 6 minus x, which is on the bottom here. And that gives me a length of 6 for this one. Together, I will have to find the area of the vertical rectangle here, as well as the area of the horizontal rectangle here. We are going to use a distributive property here, monomial times a binomial, and then combine our like terms. And there we go, our area expressed as a trinomial. Now in the question it says to express it as a trinomial in this particular form, but to determine the values of A, B, and C and calculate the area when x is equal to 2.4. So first let's list out what A, B, and C are equal to. Lining up the original form given in the question, we have ax squared plus b times x plus c. So that means the value of a is equal to 1, b is equal to positive 9, and c is equal to negative 12. Next, we're going to take the trinomial we just found, but we're going to plug in every value of x for 2.4, which is given in the question. And that gives us 15.36 square units. There we go. The next question we'll look at is question 3 on the next page here. So question 3, we already did a part of this in class. We are going to start with taking up the entire area. So here in my example, I've multiplied 4 minus y times y plus 8. And then we minus that small rectangle there. We take the given trinomial and we substitute the value of y for negative 2. Next, let's try out question number 5. Question starts off by saying we have a square garden with 3x plus 1 by 3x plus 1, and that inside the garden are 2 square flower beds, and each of these have the sides x plus 1, x plus 1. Okay, I'm just using these little ticks to indicate that it is a square. Similar to our question in class, we'll have to find out what the area of the grass is by first calculating the area of the larger garden. So here's the larger garden, minus the 2 small square flower beds inside. Let's use the shortcut. A plus b squared is equal to a squared plus 2ab plus b squared. And then we open up that second bracket and combine our like terms. There we go, and our unit here is square meters. Some of the solutions to question 7 will be uploaded for OneNote in class. Again, a reminder to use our special binomial shortcuts whenever possible. Okay, now let's look at question 8. Question 8 says the hypotenuse of a right triangle is 5x minus 6 centimeters long, and the lengths of the other two sides are 4x minus 7 and 3x minus 1. Now, it doesn't matter which one you assign which to as long as they're there. And again, the only relationship we know about right-angled triangles is the Pythagorean theorem. So we're going to write it out like this. In this question here, the special binomial multiplication we can use is a minus b squared, which gives us a squared minus 2ab plus b squared. Okay, I'm just putting a box around that first trinomial so it's clear to see which one is which. Minus 6x plus 1. Okay, next we're going to open up the brackets and combine our like terms. Now, because all we have here are plus signs on the right-hand side, it won't change any signs for us to take that away. now that I've expanded it. And all I'm going to do here is I'm going to move any x squared and any x's to the right-hand side. And we're going to do that using inverse operation. So on both sides of my equation, I'm going to be adding in total 62x minus 16x squared minus 9 squared. That's minus 25x squared in total. Also in one step, again, I'm just not showing every line of work in a separate line, and that's fine. Okay, I'm going to combine 49 and 1 in my next step as well. Okay, so note that every other term here has canceled out. On my right-hand side, all I've got left is my constant term, which is 50. And on my left-hand side, 25x squared and negative 25x squared cancels out. Negative 60x and positive 62x, I am left with 2x plus 36. And of course, we are going to minus 36 from both sides. And that leaves us with 2x is equal to 14. Divided by 2 on both sides, x is equal to 7. Now, the question is not asking us to solve for x. The question is asking us to solve for each of the lengths. So your last step is to substitute the value we found for x into each of the initial sides. And of course, we include our units as centimeters. Okay, so again, whenever you see a triangle kind of question, put it in the Pythagorean theorem relationship, as it is the only relationship that is always constant in a right-angled triangle. All right, next let's move on to question 10 on the next page. For this one, we have a rectangle with a length and width, and it's just asking for a simplified expression for the area. So again, we're going to multiply the two given trinomial and binomial. My habit is always to write the binomial first when possible, because then it's easy for me to follow. Okay, I am taking the first term and I'm multiplying that first term to each of the three following trinomials, and then I move on to the second term and I multiply the second term to each of the following trinomials. Okay, but it's totally up to you. You can put the trinomial in the front, that's fine. Note here that 3x times x squared gives us 3x cubed, and 3x times 4x gives us 12x squared. Next, I move on to my second term here, negative 2 times x squared. That gives us negative 2x squared. Finally, we come to the part where we combine our like terms. Find your term with the greatest degree first. Here it's 3x cubed, and there is nothing else with 3x cubed. Next, cross that out. I have 12x squared minus 2x squared. That gives us positive 10x squared left. And again, from speaking to some of you, this is the most common mistake here, is just collecting our like terms. Okay, I go to my next highest degree, which is x to the power of 1. So now I have negative 3x minus 8x combined together gives me negative 11x. Again, I'm crossing out those terms, and I see all I have left now is plus 2. So I just add 2 to the end as my constant. And that's it. Our unit here is square centimeters. So here's our polynomial. All we have to do now is plug in 2.5 for the value of x, and I'll let you take care of this next one on your own. Then you're just punching the whole value into the calculator. Please check to make sure you have the correct order of operation when you're putting items into your calculator. All right, question 11 here. It says dice for a children's board game are cubes with an edge length of this millimeters. Write a simplified expression for the volume of a die. Okay, we know the volume of a die is going to be area of the base times height. So 3x minus 2 cubed. Now area of the base is really just 3x minus 2 squared times the height, which is 3x minus 2. Whenever we approach a binomial cubed, break it down into a binomial squared times another binomial, because what you can do now is the luxury of using our special binomial, a minus b squared, which again gives us this particular form. So we can plug that into our first term. Again, as I mentioned before, I like to put my binomials first. So I'm actually going to put that binomial 3x minus 2 at the beginning. And then my second term, I'm going to put this trinomial, which is 9x squared minus 12x plus 4. I'm going to multiply my binomial with the trinomial now. Okay, and before you go any further in checking your answers, check this step. Does every term that I have here, do you have every term that I have here on screen? If not, then go ahead and go back to the previous step. It's probably some part in your multiplication. If you have gone to this step, then all we have to do is combine our like terms. And sorry, I just noticed a mistake here. This should be 27x cubed, since I am doing 3x times 9x squared. Okay, so this first term, when I collect them, is 27x cubed minus 45x squared plus 36x minus 8. And the unit here is cubic millimeters. All right. In B, it says the manufacturer packages dice in cubic containers containing 64 dice. Determine the volume of the container if x is equal to 4. All right, what we should do first is take the polynomial that we just derived and substitute the value 4 in. It's much easier to work with real values as opposed to polynomial terms. Sorry, that should say 4. Now that we have the volume of my entire die, I can actually go back and say take the cube root of 1000 and find out that each side must be 10 millimeters. Now another way we can find this is, of course, go back to the original 3x minus 2. We substitute in the value 4 for x. Then we have 12 minus 2 is equal to 10. Again, we know the side length is equal to 10. The reason I bring that up is because the question says it's contained in a cubic container. So imagine if my container has 64 single dice, how can it possibly be arranged? Well, it will have to be arranged in such a way that it is cube root of 64. So I have 4 times 4 times 4. So each side has 4 dice. The question does ask for the answer to be given in cubic centimeters. So I'm going to convert each of my 10 millimeters into centimeters. 10 millimeters equal to 1 centimeter. And that also tells us the volume of one die would be equal to 1 cube cm cubed, which is 1 cubic centimeters. Now, if the package is 4 by 4 by 4, so again, what that means is there are 4 dice lined along each side of this package. And each of those dice take up 1 cubic centimeters. So that means the entire volume of the package would have to equal to 4 to the power of 3, which is just 64 cubic centimeters. Okay, and you may have derived this already just by looking at the original question. As long as you show your reasoning, that should be fine. All right, last but not least, we've got 2 shapes that are equal in area. So we're just going to take the area of the square and equate it to the area of the rectangle on the right-hand side. Next, all we're going to do is isolate our variables here. Now I have an x squared on this side, so I might as well minus x squared on both sides. And I'm going to add 15 so that I move the constant to the left-hand side here. And we get 15 is equal to 2x. So 15 divided by 2, x is equal to 7.5.